Take that Madeleine cookie. We take a bite, it tastes good, and we say yum. At the very core of that yum, the earliest brain processing in a rewarding experience is the release of the chemical dopamine by the nerve cells, the neurons, in the midbrain. Neuroscientists used to think that dopamine was the sole chemical of pleasure. Now they understand that dopamine handles just one particular but very specific part of a larger pleasurable experience. Dopamine tells the brain when a reward is salient, noticeable, important, and when a reward is better than expected. Dr. David Reddish of the University of Minnesota explains dopamine's role like this. Let's say you're at a gumball machine, and you want to buy a gumball. So you put in your quarter, and due to a freak of gumball machine physics, you get 2 gumballs. This is when the midbrain releases dopamine. Dopamine tells the brain when a reward is especially good, better than expected, and to pay attention to that reward because it might be better than other things in the past for survival. So let's say you put another quarter into the gumball machine, and this time you get 1 gumball. This time the midbrain does not release any excess dopamine. It's not that the gumball doesn't taste good, it's just not a reward that was better than expected. Just to push your luck, you put 1 more quarter into the gumball machine, and this time you get no gumball. This time the neurons in the midbrain release less dopamine because this reward was worse than expected. It's in this way that dopamine acts as a learning signal to help the brain identify, prioritize, and then anticipate new and unexpected rewards over older predictable rewards. Dopamine is a chemical of pleasure, yes, but it handles one specific piece of pleasure. Dr. Terry Robinson and Dr. Kent Berridge of the University of Michigan believe that dopamine is more about drug wanting than drug liking. It's the first in what will be a series of neurochemicals, a kind of hedonic cascade that will create that larger pleasurable experience. What all natural pleasures have in common, things like food and sex, is their ability to release dopamine. But drugs cause huge surges of dopamine, far greater than the brain was ever meant to handle. Drugs fool the brain into thinking they are much, much better than expected. Every time the addict uses the drug and they get that surge of dopamine, their brain gets a message that the drug is better and better than expected, even though it's not, and has greater and greater survival value, even though the drug doesn't deserve that survival value, and it goes higher and higher on the survival priority list. And the drug climbs the survival list until finally it is in the #1 spot. Now for the addict, the drug is survival. And it's this irrational assignment of value that lies at the very heart of one of the most frustrating but fascinating features of addiction: persistent drug use despite negative consequences.